All right, so let's talk about, I've got a couple of new projects and another one I'm working on. I'll have another big one probably next week. Anyway, this one here is one not that different than the game of life, sort of fun but not too hard. You have a cavern with a lot of fish, and the fish have an energy level that goes from 0 to 10. Actually, I'm not, yeah. And so when they reach a number above 9, they will flash and use up all their energy. But first, now in every time interval, all the fishes go up by 1 in energy, and anything next to a flashing fish goes up by another 1. And any fish that flashes will always end up at energy 0 after this. So if you take a small one like this, you'll see the situation. So here we have a situation where these guys are at 9, so when you add 1, they're going to turn into 10 and flash. So all the 9s are going to flash. So by the next step, everything goes up by 1, so the 1s go up to 2, but the one in the corner has 1 9 next to it, so it gets an extra 1 and goes up by 3. This one has 2 9s next to it, that one has 3 9s next to it, so 3, 4, 5, 4, 3 is what you get up here. They each go up by 1, and they go up by 1 more for each fish that flash next to them. And it's important to understand the order of operations. So these fish flash, and in the same step, they add 1 to the one in the middle. So this is 1. You add 1 for time, and it goes to 2. You add 8 from all these 8 flashing fishes, and it goes to 10. So the one in the center flashes 2. And my first thought was maybe the one in the center wouldn't flash until next time, but it flashes right away. And then I thought the one in the center would make all these 9s to turn into a 1, but the rule is any fish that flashes stays 0. So the additional energy from this one that flashes does not go to the ones next to it. So you end up with all 0s in the middle. That's not too hard to implement, but that's the rule. And so now at the next step, you just add 1 to these, and none of them flash because none of them goes over 9. So that's a start. And so the example one here goes like this. You can just set it up and then see it go and get it right. What's interesting is the first puzzle is just to predict the total number of flashes after 100 steps. So that's a simple enough task to do, starting with different data. The next one is more interesting. It's not terribly obvious from the looks of this, but notice how there are regions that are all the same. All these 3s are the same, all these 2s are the same. I think that is ultimately a consequence of that rule, where ones that flash all have to go to 0, even if they really got extra energy. So regions will all flash together. And what happens is there comes a time when they will all synchronize. After 193, you'll have this. So the 7s are all going to go to 8s, the 8s are going to go to 9, the 5 is going to go to 6. Next time, these 9s are going to flash, and when they flash, these 8s are going to flash because they get 1 for time and another 1 here, and the flash is going to progress down through this thing all in one round. So after step 195, the whole thing is 0s. Even the one in the corner that's a 6 is going to go up to 7, and it has 3 neighbors that flash, so that's 8, 9, and 10. So this situation turns into this, which is interesting, and it makes me think that the initial condition probably doesn't matter. You could probably start it with any random condition, and after enough flashes, it'll do this, and then they're all the same. So it's an interesting game. I suspect that all plays of the game end up in the same place, but I haven't proven that, but that's interesting. Anyway, so now you just have to find which step is going to have all the fishes flash. So anyway, I thought that was a sort of interesting one. You get to practice setting it up and making a grid and processing simple calculations on it. It's not something you haven't done in earlier projects, but it's an okay one to do. All right, let me stop this one.